All right, hard disk drives. So what do we use a hard disk drive for? We use hard disks for permanent storage. So hard drive is our most important storage device that we use in the computer. It stores our operating systems, our applications, and all of our data. So when you take a photo or you get some music and you download it to your machine, it's downloading to your hard drive. When you turn off the power, the data on the hard drive will still stay there. I could take the hard drive out of your machine, walk it across the room, plug it into another machine, and that data will still be there. With RAM, if you guys remember, we talked about it's temporary. As soon as you take away the power, the RAM dumps its contents. Hard drives can be internal or external. So if you have it external or internal, they're built the same way. The only difference is the actual casing. So if you actually open up an external hard drive, like a USB hard drive, inside is a laptop internal hard drive. That's all it is. If it's the larger size one, it'll be a desktop one. They come in 3 different sizes, 1.8, 2.5, and 3.5 inches, and we'll talk about that as we go through. All that's talking about is how big the physical disk inside is. That platter that you see, that gold platter. These are made out of 1 or more double-sided platters, and they're made from aluminum or glass, and they're coated with a magnetic surface. So that magnetic surface can actually hold the 0 or 1 bit of electricity that we're giving it. You'll see nowadays commonplace sizes starting at 500 gigabytes, which is half a terabyte, all the way up to 3 terabytes or even more. I've seen some out there now that are up to 6 terabytes in size. These things are getting huge. When hard drives first came out, my first hard drive I had was 5 megabytes, which is like nothing, right? But nowadays, they're really, really large sizes of hard drives, which gives you a lot of storage capability. Just to give you an idea of storage, if you take like an hour-long or a 2-hour movie, like a copy of a DVD essentially, it's about 2 gigabytes in size. So, 500 gigabyte drive, you can store about 250 movies. If you look at like your Xbox with video games, those Blu-ray discs that they use for that, it can be the high definition discs they use for Xbox. Those are about 50 gigabytes each. So your internal Xbox usually comes standard with a 500 gigabyte hard drive. If you put 10 games on it, you've filled it up. So then you have to add an external drive to give you more storage space. So things that affect our performance for a hard drive. The fastest, highest performing connection that we use for a hard drive is what's called SATA. And SATA, it's kind of like USB. It's a cable type connection that we use on the internal side of our computer. When we opened up our cases the other day and we were putting parts in and out, I showed you guys that SATA connector, right? It's that 7-pin L-shaped connector. Ours was white with a black cable, and they connect to the side of the hard drive. They'll operate at either 1.5, 3, or 6 gigabits per second, depending on the version of SATA. The latest version is SATA version 3 that operates at 6 gigabits per second. The spin rate. So inside we have this big circular platter where everything is stored. And as you can see, we have these read-write arms that actually read the data on the platters. And so the disk has to spin to the right portion for the data to be recovered from it. If you want to think like an old record player, right? If you want to play the right song, you have to get the needle to the right part of the disk. Same concept here. Well, if your disk can just go faster, you can access the data quicker. If your disk goes slower, your access to data is slower. And so the slow speed one, which is in what most desktop and laptop computers have, is called 5,400 RPMs or revolutions per minute. It's spinning a little over 5,000 times every minute. If you get a faster one, you're going to get 7,200, which is pretty typical in higher end model computers and laptops. If you go to server environments, they'll even have some that operate at 10 to 15,000 revolutions per minute. Some of the good ones that do that are things like the Barracuda drives. They are known for having a very high speed turn rate. The other thing that can help speed up your hard drives is if it has a buffer. So again, hard drives are kind of slow because they have to spin around to the right part of data, and then it sends this data to the memory of the computer. The memory operates very fast because there's no moving parts to it. And so what the hard drive manufacturers have done is they've added a buffer, a piece of memory inside the hard drive. So as it's spinning, it gets that data, fills the buffer, and then the buffer transfers that data to memory. And so if you have a larger buffer, like 64 megabytes, it'll operate faster than one that has an 8 megabyte cache or a buffer. A cache is just like a buffer, like we talked about the cache inside the processors before. So a lot of people are starting to see these come to market. They're called solid state drives, SSDs. And these are awesome. They are fast and they are durable. There's no moving parts. So if you have a laptop with a solid state drive and you're shaking it, moving it, you don't have to worry about the hard drive getting broken, right? Because there's nothing to move. If you look on the top here, we have a picture of a regular hard drive. If you look at the bottom, we have a solid-state drive. Notice they're the same physical size. The big difference is we're using memory chips, much like a thumb drive, like a USB thumb drive, store all of our data. The big problem you have here is that they cost a lot more money. They're a lot more expensive for a same size storage than a traditional hard drive. The SSD, it's going to emulate a hard drive for you. It's used very heavily in notebooks, netbooks, ultrabooks, which, well, they want fast performance and a lightweight solution. And they also use less power than a traditional hard drive because, again, there's no moving parts. So if you look at like the MacBook Airs, for instance, they were always kind of known as, oh wow, those things are awesome. They can get 10 to 12 hours of battery life on a single charge. One of the ways they did that is they were using solid-state devices. They were one of the first mainstream laptops to use it. Nowadays, you'll find it in tons of machines out there, including your Windows Surface tablets. Pretty much any of your tablets are going to use this. They're not going to use a hard drive. And then a lot of the netbooks and notebooks will use this as well. They do come in 1.8 or 2.5 form factors. Again, that's just how big that circular disk is, which defines how big across the hard drive is, or the solid-state devices. If you have a desktop, they use either a 3.5 inch, it's a larger size. So if you're going to put one of these solid states in there, you have to get an adapter, which is basically just a metal bracket. So you screw it to the bracket, and then the bracket goes into where the normal hard drive would fit, just so that it fits the right size. There's two types of solid-state devices. One is the multi-layer cells, and one is the single-level cells. The multi-level cells, or MLCs, are cheaper, but because they're cheaper, they're also slower. These were used, if you ever saw those Acer OneNote laptop, they were like 10-inch little mini laptops. They were some of the first to have solid-state drives, and they were using multi-level cells because they were cheap. These were like $200 laptops, okay? If you're dealing with these single-layer cells, they're much more expensive, but they're much, much faster. My particular laptop, I have this OWC solid-state drive in there, and the thing operates at 6 gigabytes per second. Very, very fast. And again, no moving parts, extended battery life, lots of goodness to it. But they're very expensive. My particular SSD is 120 gigabytes. I paid about $300 for it. At that time, for about $50 to $75, you could have gotten a 1 terabyte drive if you got a traditional drive. So you're getting about 8 to 10 times less storage for about 3 times the cost, right? They've come down significantly in price over the last couple of years. Nowadays, you can get solid-state drives in the $50 to $100 range for a decent one. But again, you're going to be talking about an eighth of the size comparatively for storage. So a lot less storage, but it is a lot faster. And so because SSDs were so expensive and traditional hard drives were relatively slow, what they did was they came up with this hybrid drive that kind of combines both of them. And so what they do is they have the large traditional disk being used for the majority of the storage, and then they have a small, like 8 gigabyte SSD combined with it to use as a buffer. And so maybe the operating system would get stored on that SSD portion, and the files would actually be stored on the hard drive portion. And this would end up speeding up your system. These have fallen out of popularity because SSDs are dropping in price. So most people will either go full SSD or full traditional. The hybrids aren't nearly as popular as they used to be. But the whole idea was to try to speed up the performance and use those benefits of an SSD without driving the cost way up. These were a lot more in line with the traditional hard drive cost. So how do you connect a hard drive? We have lots of different ways to connect hard drives, but the one that you're going to find most often now is a SATA connector, SATA, which stands for Serial Advanced Technology Attachment. That's that 7-pin L-shaped connector we were talking about. And you can see it here on the top. I circled it in yellow. That is a serial ATA or a SATA connector. It's what it looks like. It's circled in red, the middle one there. PATA is the older style, called a parallel ATA. This is what we were using in the 80s and 90s, and even into the 2000s. I haven't seen a machine using this in about 5 years. It's a very old technology, and a lot slower than SATA. It uses a fat ribbon cable. It's a 40-pin connector. As you can see, circled in red here. It does use Molex for its power, which is circled in yellow there. The thing about the parallel ATA is because it's parallel, it can actually have 2 devices operating on the same cable at once. And this is where we need to use those jumpers to do master-slave relationship. With SCSI, we're talking about the small computer systems interface. This allows us to do that daisy chaining of 7 to 15 drives. Usually used on servers for tape backup drives now, not commonly used for hard drives. Most things now have moved to SATA for everything. And then we also have floppy drives, the 5 1/4, which are those big floppy disks, 5 1/4 inch, or 3 1/2, which were the floppy disk inside of the hard casing, that we all used probably back in high school. If you look at the save icon in Microsoft Word, that's what a floppy disk looks like. We don't use them very commonly anymore. Again, the last 5 years, it's pretty hard to find a system that actually has a floppy disk drive. You can also hook up things externally. And we talked a lot about these before, but we have eSATA, which stands for external SATA. It looks the exact same. In fact, it uses the exact same cable as internal SATA does. The only difference is the port is physically sitting on the outside of your machine. So you can plug it in like a USB drive would. We can use USB, either 2.0 or 3.0. We can use FireWire, either 400 or 800. We can use SCSI as an external interface, or we can even use a network connection, like fast Ethernet or gigabit, for a hard drive. You can buy a lot of these cloud drive devices. You plug them into your Wi-Fi access point, and then anyone on the network can get access to your data that way. It's good for a temporary file storage solution. So we talk about SATA. This is used for our hard disks and our optical disks, so DVDs and CDs. You use one cable for one device. And here's a picture of what the cables look like. Like I said, it's a L-shaped 7-pin connector. The smaller one is for data. The larger one, which is a 15-pin, is used for power. We talked about that back in the power lecture. There is a jumper on some of these devices that can be used to reduce the speed. So they can go to a 3 gig or a 6 gig speed input. The older style, again, was 1.5 and 3. The newer style, SATA 3, uses 6 gigabit per second, which is very fast and very useful. Again, there's 7-pin cables for data, 15 pins for power, and you can convert any SATA port on the motherboard to a eSATA port by getting a header, and it'll just connect from the outside of the computer into the motherboard. PATA, that parallel ATA that we were talking about, in the old days we used to call this IDE or EIDE, Enhanced IDE. This has to use jumpers, so you can see in the bottom right there, we have the jumper dictating that this is a master drive or a slave drive, because we would have this 40-pin cable, and we would have 2 connections on that cable, so you could hook up a hard drive and a CD at the same time. But one has to be primary, one has to be secondary. That's that master-slave relationship. The blue connector goes to the motherboard, the black goes to the primary, the gray goes to the secondary device, and you want to make sure you set your cable, your jumper to either master slave or cable select. Like I said, you're not going to see these very often anymore. They're older technology. In fact, none of the machines we have here even have this for me to show you a real-life example of it. SCSI, again, that's another older technology. We talked about this briefly in the input-output lesson. It is a single SCSI can support a daisy chain of 7 to 15 devices. You can see here this SCSI cable and how it's got this one cable can have 7 devices on it. Each of them has to have a device ID configured using either dip switches or a jumper. And the speed ranges, they start out as low as 10 and go all the way up to 320 megabits per second. But 320 megabits per second is still about 20 times slower than SATA 3, right? The SATA 3 does 6 gigs per second. So we want to be able to use that instead. And it's used for hard disks or tape drives in server environments. Again, you're not likely to see this in most cases nowadays because it is an older technology. Everything's being replaced by SATA. Here's what an eSATA port looks like. As I said, it looks just like a regular SATA port, right? All the E means is it's external. It's on the outside of your case. You can see we still have that L-shaped connector. It uses a header cable to the internal port on the motherboard to bring it to the outside of the case. In your BIOS, one of the things you can set is what's called AHCI, which is part of that power management settings. And if you have AHCI enabled, it allows SATA to allow hot swapping like a USB drive does. So if you guys have used a USB thumb drive or a hard drive before, you know that when your computer's on, you can plug it in, it automatically detects it, you can do your work on it, and then you can eject that, and you only have turned off the computer. If you have AHCI enabled, SATA will work the same way. The host adapters can be added into any open PCI slot, either an X1 or an X4. And it's comparable to USB 3.0, right? USB 3.0 operates at 5 gigs. SATA will operate around 6 gigs, right? So they're fairly equivalent. Yes, question? Hot swap. So what I mean by hot swap is that you don't have to shut down the computer to add or remove the hardware. So if you don't have hot swap, you have to actually physically turn off the computer and power it down to put the hard drive in. With hot swap, you don't have to do that. You can actually just pull the drive out or add a new drive just by cabling it in, even while the computer's on it. Like when you use a USB thumb drive or a USB hard drive, they're hot swappable devices, right? If you take your iPod and plug it into your computer, you don't have to shut the computer off first. You just plug it in. That's hot swap. You can do that for the hard drive too, if you're using eSATA or USB for it. Yep. You wouldn't do it for your main operating system hard drive, right? But if you had a secondary hard drive with all your photos and videos and stuff like that, that's where you would use hot swap for it. Yeah. If you're going to pull the system hard drive out, your system would crash because it wouldn't have access to it anymore, right? But yeah, so for data drives, you can do that. So with that hot swappable drive interface, right, we can do this for FireWire, we can do it for USB, and we can do it for eSATA. And when the drive is connected, Windows will automatically recognize that drive for you. You can eject the drive safely by going to safely remove hardware in the notifications area by the clock. And if you don't do that, you could lose your data, right? So you want to make sure you safely eject it first. This is an example here of a server that has 4 drives, and you could pull them in or pull them out as hot swappable drives. If you look at the computers at your feet, you can see they have a hard drive with a silver key. We can actually take out that drive and pull it, put a new drive in. And we can do that hot swappable using eSATA as well. And the reason why is as we have different classes, we put different operating systems on here or different programs. We can just swap out the drives and we'll use them that way. So, yes. So ejecting the drive safely in Windows, in the bottom right corner, there's a little button by the clock that says, safely remove hardware. You click that and then it'll say, your drive is now safe to remove, and then you can yank it. Usually do that, sometimes that happens. Yeah, yeah, so what determines whether you lose data if you don't do it? So it's a matter of how fast the drive has buffered. So for instance, let's say I have a thumb drive that I plugged in, right? That's usually the most common thing that people just yank. So I plug in my thumb drive and I'm copying files to the thumb drive. And in the middle of it copying, I yank the drive. Well, you're going to not have a complete file, right? Or if I'm copying files over and as soon as it finishes copying, I yank it out like a second later. Well, just because Windows says it was finished copying doesn't mean it actually did. Sometimes there's stuff happening in the background. It's still part of the buffer process. So it hasn't quite finished copying all that file over. You can lose data that way. If you have it in there and you copied files 10 minutes ago, you went to lunch, you came back, and now you yank it, you're probably not going to lose anything. But best practice is you do want to safely eject so you don't lose data. And with thumb drives, it's not as big of a deal because they copy much quicker. With traditional hard drives where you have a spinning disk, it's much better to safely eject. So which of the following hard drives would be considered the most likely to survive a fall? So if I'm going to drop a hard drive, should I drop the SCSI hard drive, the SSD, the SATA, or the IDE? And the answer is none of them, right? One of them would survive the fall better than others, right? Which one? D, right? The SSD. And why? Because there's no moving parts, right? When you have a moving parts of this rotational disk, which the SCSI, the SATA, and the IDE do, those will all, if you're using a traditional hard drive, that platter can actually become loose or dislodged, and then you can lose your data completely.